We are going to do an in-class review for exam 1. So on your exam, I'm going to ask you to do the same thing. If you need to take derivative of a constant, it should equal to what? 0. If we need to take derivative of x raised to n power, we will bring down the n and then write down the x. Your exponents need to go down 1 power, right? The next one is the product rule. So the product rule say you write down the first term first, take the derivative of the second part. This is going to be addition. Start with the second part again, and then take the derivative of the first part. For the quotient rule, the order does matter. First, the bottom part need to be square, and then the top part, we started with the bottom. Take the derivative of the top. This time it's going to be subtractions, and do the top part, take the derivative of the bottom part, like that. Okay, the very last one is chain rule. So for the chain rule, we are going to take the derivative of the outside part first, meaning you bring down the n, and you have f of x. Exponents need to go down 1, and then you will take the derivative of the inside part. Okay, so we will have one part like that. So you just write down the rule, and then you will get a few points for that. After that, we are going to do a few examples for limits. So remember, if we are trying to find limits, there are 3 things we can do. We can first try to plug in x. That would be the quickest way if it works. If it doesn't work, meaning if you have a fraction with 0 for denominator, it's not okay. Or if you have a square root with negative inside, it's not okay. Those you need to move on to the second step. The second step will tell you to try to factor and reduce first. After you factor and reduce, then you can try to plug in x. But if that doesn't work, then you will move on to the last step, which is set the table. Okay. We will see for number 1, we have a few questions here. Start with the first one. I have limits as x approaching to 3, the plus sign mean coming from the right hand side, 20x squared minus 5x plus 1. So I'm going to try to plug in number. So we have 20 times x. I'm going to plug in 3 here to the second power, minus 5 times x, we will plug in 3 and then adding a 1. So make sure you follow the order of operations. So if you follow the order of operations, then you will do the exponent part first, right? So this means 20 times 9 minus 5 times 3 is 15 plus 1. 20 times 9 is going to be 180 minus 15 plus 1. So they're in the same order. We can do from left to right. This is 165 plus 1 is 166. So just plugging in number work for this particular question. So that would be the quickest way that we can do it, right? So for the B part, we are taking limits as x approaching to negative 2. It doesn't have plus or minus, mean both sides. We have this. Can we just plug in number? So if I just plug in number, I have 3 times negative 2 plus the 6, and then negative 2 squared minus a 4. I can already see the bottom part is going to be 0, right? 4 minus 4 is 0. So that is not okay. If it's not okay, we can move on to the second part, which we factor and reduce, right? So we're going to factor and reduce this. Before you plug in number, you should always carry the limit step. So if I factor, the top part look like that's a GCF of what? 3. If we pull that out, we're going to have 3 times x plus 2 over the bottom part is x squared minus 2 squared, right? So it's going to be different of 2 squared, x plus 2, and x minus 2, right? So it looks like I can cancel the x plus 2 parts. Now I'm going to try to see if I can just plug in number. So 3 here, and then I'm going to plug in negative 2 at the bottom, and then this you need to minus a 2. that will give me 3 over negative 4. So it's not a 0 at the bottom. That seems to work out. So it's negative 3/4, right? The second part, we can factor and reduce and make that work. So next we're going to write down C. So for C, we have limit as x approaching to 6. And then we have x and then x squared minus 36, right? So if we try to plug in number, we have 6 squared minus 36. Look like it's not going to work because it's 36 minus 36. We're going to get a number over 0, right? So that's not okay. Can we factor and reduce? If we factor and reduce, we are taking limit as x approaching to 6. On the top, we have x. At the bottom is difference of 2 squared, right? So this is x plus 6 and then x minus 6. But there's nothing to reduce, right? Going to plug in 6 here again. 6 plus 6 would be 12. Multiply a 6 minus 6 is a 0. So we still end up with number over 0, right? So it's still not okay. So this time we will have to set a table. So how do we set table? The table, basically, you will put the x value on top and the y value at the bottom, and you want to see the number close to as x approaching to 6, what is the trend for the y value. So number very close to 6, we can have maybe 5.999 and then 5.99. And then on the other side, we can have 6.001 and 6.01, something like that, right? So we want to check and see what will happen if you plug into the calculator. If I am doing on the left-hand side, 5.999 divided by, I'm going to have a parenthesis of 5.999. Need to be square, and then minus of 36. Let's close that. I got a negative 499 point something, right? So I'm going to write that down. Negative 499.96. So I'm going to do 5.99 divided by parenthesis double. 5.99 need to be square first, and then subtracting a 36, close it. So this one is negative 49.96. So it looked like decreasing pretty rapidly. So I'm going to say this is going toward negative infinity as it approaches to this side. And if I put 6.001 divided by double parenthesis 6.001 square, subtracting a 36, close it. I got 500.04 positive. And then on the one next to it is going to be 6.01 divided by double parentheses 6.01 need to be square, subtracting a 36, close it. It's going to give me 50.04. So again, on this side, it looked like increasing pretty rapidly. So I think it's going to be approaching positive infinitive. So from the left and from the right, they settle in different number, and also they are infinitive and negative infinitive. So for sure, the limit does not exist. Okay, that's for C. Let's move on to D. So D is a little bit different. D need to figure out limits as x approaching to infinitive. We have 8x to the third power minus 5x over x cubed plus 7x squared. So for this one, is limit as x approaching to infinity. Remember we said we are going to divide each part with x to the highest power from the bottom, right? Okay, so each part, so I haven't plugged in anything yet, so I have to still carry the limits. Each term, each part of the fractions is going to need to divide it by x to the highest power from the bottom, which I see is x cubed. 8x cubed, 5x, and then x cubed, and 7x squared. The first one, again, we haven't plugged in anything yet, so I cannot drop the limits part. This one cancel and cancel, I just have 8. And then minus, I will end up with 5 here with the x squared. This one will just be 1 plus, this is 7 over x, right? So anything with x in the denominator, because you're going to plug in infinitive, is going to be such a small number, becomes 0. So you will end up with 8 over 1. When you end up with 8 over 1, there's no x to plug in anymore, right? So it's going to be just 8 over 1, which is just 8, right? So that would be your answer. So the second part, we are going to use a picture, and then we're going to need to answer a few questions. So looking at the handouts, I'm going to draw a picture on it. The picture is going to have two curves there. And then look, I have some asymptote guiding the graph like that. Okay, this is your one here, so, and they say going from, okay, so this is the given graph, and if x is approaching from the positive side, right-hand side, as x approaching to -1, I can see it's pointing up here, right? So the y value is going to be positive infinitive, right? So as x approaching to -1, the y value going up here, positive infinitive. Second part is x approaching -1 from the negative side, from the left-hand side, I can see y is going down like this, right? So it's heading toward negative infinitive. And this one have no positive or negative side, just approaching to -1 for x as limit of x approaching to -1 from both sides. So because this is two different numbers and they are infinitive, so I'm going to say does not exist. Okay, so next is D. We see x approaching to infinitive, so x approaching to infinitive is going to be this here, right? So it looks like it's approaching to y equal to 1, 2, 3, and 4, because there seems to be a horizontal asymptote of y equal to 4, right? And then where is the function discontinue? So the discontinue part is going to be this vertical asymptote, look like at x equal to 1. And then the function is continue everywhere else, right? So that would be 1 with the picture. Next part, we are going to look at number 3. Found the x value at which each of these functions is continuous. Use the interval notation and show the steps. So I can see the first one is a degree 6 polynomial function, right? I know this is going to be an even leading power with a positive, right? So I know the n is going to be both sides up, and then it's going to have how many turns? 5 turns, right? 1, 2, 3, 4, 5, like that. So if a graph look like that, it looks like it's going to be continue everywhere, right? So I'm going to say it's going to be continue negative infinitive to positive infinitive. The next one is going to be a rational function. It looks like it has a denominator, and we want to make sure the denominator cannot equal to 0. So, and it looks like a difference of 2 squared, x squared, and 10 squared, right? So basically we have x plus 10 and x minus 10 cannot equal to 0. So we are going to know x cannot equal to negative 10 and x cannot equal to positive 10, because if you plug in 10 or negative 10 in there, it's going to make the bottom part equal to 0, right? So you're skipping negative 10 and 10, but the rest of them would be part of your continue part for your functions. So I can say it's going to continue from negative infinity to negative 10, parentheses, pick up from negative 10 to 10, and then continue 10 to infinity, right? So the only thing you're skipping is the negative 10 and 10. Are we okay? So the next one is a little bit longer because it needs to do the 4 steps. So this is number 4. G of x equal to x squared plus 5x, and then we need to use the 4 steps this time to do limits as h approaching to 0, f of x plus h minus f of x over h. So if you're very good, you can maybe do it in 1 step, but if you need to break it to 4 steps, it's perfectly fine. That's what they want you to do. Step 1, we're going to need to find what is f of x plus h. Okay, so f of x plus h means whenever you see x, plug in h of h. So something squared plus 5 times something, right? And we're going to plug in x plus h. So hopefully by now you know what x plus h squared is, but if not, x plus h squared is x plus h times x plus h. And if you FOIL it, it would be x squared plus xh plus xh plus h squared, right? Like that. The middle part can turn into plus 2xh, right? So this is actually kind of a formula of a plus b perfect square. So I have x squared plus 2xh plus h squared. And then over here, we are going to add 5x at 5h. Okay, nothing else we can do. So that's the step 1. Step 2, I'm going to need to use what I just get, f of x plus h, need to subtract the function, right? Write down what we just get, x squared plus 2xh plus h squared plus 5x plus 5h. Need to subtract this whole function, meaning you need to distribute the negative inside, right? So that would be minus x squared minus 5x. A lot of time they can cancel something. So if nothing can cancel, you probably did something not quite right. Okay, so I can cancel my x squared. I can cancel my 5x. Okay, so that would leave me with 2xh plus h squared plus 5h. All right, so that's the second step. And the next step say, whatever you get there, f of x plus h minus f of x need to be divided by h. So write down your answer, 2xh plus h squared plus 5h need to be divided by h, because every single term has an h. So we can cancel an h from one of each. So that would give me 2x plus h plus a 5, right? So that's step 3. The last step is step 4. We are going to take limits as h approaching 0 for the answer you just got, right? That will be 2x plus h plus 5, and the only thing you can plug in is this h to become a 0, so the answer is going to be 2x plus 5. So this is taking the derivative with the longer way, with the 4 step, and you can double check your answer because you know the shortcut, right? This is 2x, this would be a 5. So that's your answer. Okay, so that would be number 4. You need to be able to do one like that. Okay, number 5. At number 5, we are using the same function we found from number 4, and we want to find the instantaneous rate of change at x equal to 6. So instantaneous rate of change is like slope of tangent line. So this is a and b. So a is same as slope of tangent line, or instantaneous rate of change at x equal to 6, which means I want to find f prime of x at the value of x equal to 6, right? This slope at x equal to 6, and we found the f prime of x, or we can just do that very quickly. F prime of x is going to be, this is x squared, taking this derivative would be 2x, right? And then 5x will become just 5, right? So this is your f prime of x. I want to know at x equal to 6. So I just need to plug in 6, right? For the x values. So this would be 2 times 6 plus 5, which is 12 plus 5 equal to 17. So 17 is the slope of tangent line at x equal to 6, right? This is also the instantaneous rate of change at x equal to 6. Are we okay? Next, they want to know the equation of tangent line at x equal to 6. Equation of tangent line, we need an equation, then we need slope, and also a point, right? And we can plug it in y minus y1 equal to m times x minus x1. This is the point slope formula. We already get the slope earlier equal to 17, right? And then I need the point, and I know x is going to be 6. To find the y value, we need to plug into the original functions. F of x is x squared plus 5x, so make sure you don't plug into the slope. You need the original function, and we plug in f of 6 equal to 6 squared plus 5 times 6. 6 squared is 36, right? 5 times 6 is 30. Altogether would be 66. So the point itself is going to be x equal to 6, y equal to 66. A lot of 6. So we're going to plug in the points along with the slope. So it's going to be y minus, my y value is 66. My slope is 17. My x value is 6. And then we're going to need to distribute and try to simplify this a little bit more. We are going to have y minus 66 equal to 17x, and then 6 times 17 is going to be subtracting 102. And then we are going to move the 66 to the other side. So that will give me y equal to 17x minus 36. Okay, so that would be the equation of tangent line. At x equal to 6. All right, so that would be number 5. Okay, number 5C, we need to find the value of x when you have a horizontal tangent line. So what we know about horizontal line have a slope of what? And will equal to 0. For a line that is horizontal, the slope will be 0. And we know the f-line of x, the tangent line slope, is going to be 2x plus 5, right? So all we need to do is set the slope of tangent line equal to 0 to find the x value, right? So we will set 2x plus 5 equal to 0. Solve for x. We can subtract 5 first. 2x equal to negative 5. And divide 2 both sides. So x equal to 5 over 2, right? Negative 5 over 2. So that's your x value when you have a horizontal tangent line, because the slope will equal to 0. Okay, let's move on to number 6. So if you look at your handout, number 6 to 10, those are the questions that we will apply the shortcuts with the rule. We will take the derivative of them, starting with number 6. So 6, we have the functions equal to 10x to the 4 minus 7x cubed plus 5x minus 2. So when we take this derivative, the first one have a number, right? So it's just 10, and then take the derivative of this part, which we will bring down to 4x and 1 degree down, right? The next term, the 7 stay here. Take the derivative of x cubed, we have 3x and then 1 degree down, right? When you have just 5x, it would be just 5, the x turn to 1, right? And when you have a number, it's going to turn to 0. So that would give me 40x cubed minus 21x squared plus a 5, and that would be the appline of x. Are we okay? Number 7, we have h of x equal to negative 13x squared plus 5x minus 9, and then an x at the bottom. This one, if you don't want to apply the quotient rule, you can break the original function into 3 fractions because they all share x as the denominator, right? First one is negative 13x squared, this is a 5x, this is a 9 over x. So we can rewrite that as, after you reduce, negative 13x, right? So you get rid of 1x and 1x. 1x and 1x, so this is plus 5. And the last one, you can write that as exponents. That would be 9x raised to negative 1, right? So I can take the derivative of that. That's your h of x. If I take the derivative of h prime of x, the first one is going to be negative 13, stay like that. X will turn to 1. And a constant, taking the derivative, is going to be 0. And the last one would be a negative 9, stay there. Bring down the exponent. And then your x is going to be 1 degree less, right? So that would give me negative 13, 0 is gone. This is negative times negative is positive 9, x negative 1 would be negative 2, right? I cannot leave negative exponents as my answer, so I'm going to rewrite that as negative 13 plus a 9 over x squared for my h prime of x. Are we okay? Alright, so number 8, we have h of x equal to 8 square root of x. The good rule of thumb is we write that as exponents first. So 8, this is x raised to what power? This is 1/2 power. Using that, we can try to take h prime of x. We have the 8 here. We will bring down the 1/2 power. And then x need to go down 1 exponent, right? So this is going to be 1/2 minus 2 over 2. X times 1/2, x raised to negative 1/2. So now I cannot have negative exponents, so I'm going to put them in a fraction form. The 8's go to the top, the 2 in the denominator. This guy has a negative exponent, so it needs to go down here, become positive like that, right? And I can see my 8 and the 2 can reduce by 2. 2 times 1, 2 times 4. So 4 on top, you can write as x raised to 1/2. That would be fine. Or you can write that as 4 over square root of x. Both of them are correct. Are we okay with number 8? Okay, let's move on to number 9. So number 9, we have g of x equal to x divided by x minus 10. So this one we will need to use the quotient rule. So g prime of x, quotient rule say the bottom part need to do what? Square. And then you start with the bottom part. And then take the derivative of the top. Add or subtract. Subtracting the top part times the derivative of the bottom, which is this guy, x minus 10 prime. So make sure you pick this one, not that one, okay? Now we have x minus 10 squared at the bottom. The top we have x minus 10. Taking the derivative of x will give us just 1, right? Subtracting, this is x, need to multiply 2. The derivative of x again is 1. And then the 10 is a constant. Taking the derivative will turn into a 0, right? So I need to have x minus 10 here, and then this just minus x, right? And then x minus 10 perfect square. Look like I can cancel out the x. Final step, g prime of x is going to be negative 10, and then x minus 10 perfect square. Are we okay? Alright, so number 10, we have the functions equal to 8x minus 5 to the 6th power. So this one would be a chain rule because it's like a function in here and raised to a power, right? So the f prime of x we're going to need to do the outside part first, which will bring down the 6. And then the 8x minus 5 need to go down 1 degree, become 5. And then take the derivative of the inside part. Like that. So we did the outside part. And then the inside part. Okay. That will give us just 8x minus 5 to the 5th power, and take the derivative of this guy. We're going to have 8 times 1, right, basically, and then minus a 0. That's it. Okay, that just means the 6 need to multiply to an 8, right? 6 times 8 is going to be 48 times 8x minus 5 to the 5th power. Are we okay? So that would be your answer for number 10.